All right, well, I'm going to see how this works here. I'm going to be working on the solutions for the, let me see how this writes, 0303 Exam 3 Review. So number 1, A, we have negative 9x squared plus 12 equals 0. So what we want to do here is solve this quadratic equation. We want to notice that we have an x squared term and that we have a number, and we do not have an x term by itself at all. So whenever we don't have an x term, we usually solve this the same way. We isolate the x squared. To do that, we will subtract 12 both sides. When we do that, we get negative 9x squared equals negative 12. Now I will divide both sides by negative 9. So come in here, negative 9, negative 9. That leaves me with x squared equals, over here, negative over negative is positive, and then 3 goes into both of these, so I can reduce the fraction to 4/3. Now to solve for x, we'll come in and we will take the square root on both sides, like this. Oops, I did plus minus on the wrong side. Square root of both sides, and the square root of x squared is x. Over here we get plus or minus the square root of 4/3. Now we can leave it like this. You could also take the square root on top and bottom separately. So square root of 4 up there is 2. Square root of 3 we can't do anything with, so you could use that answer. And you could even, if you wanted to, get on your calculator and figure out, first of all, what 4 divided by 3 is. That'll be 1.33 repeated. And then take the square root of that, which I'll do real quick. I would accept any of these answers. You would have gotten plus or minus 1.15, rounding, something like that. So any of those answers are acceptable. Okay, let's move on to part B. So for part B, you have 5 minus 15x squared equals 0. Again, we have an x squared here. We have a number by itself. We do not have an x term at all. X by itself. We have an x squared, but we don't have x by itself. So same technique. I want to get the x squared isolated. I'm going to choose to go ahead and subtract the 5 on both sides. When you do that, negative 15x squared is on the left. On the right, 0 minus 5 is negative 5. And then again, I'm going to divide through by the coefficient in front of x squared, which is negative 15. And I'll go ahead and get, let's see here, my x squared on the left. On the right, a negative divided by a positive is negative. And 5 goes into both of these, so I get 1/3. And now what I need to do is take the square root again. So square root both sides, plus or minus over here. We get x equals plus or minus the square root of negative 1/3. And be careful here because we have a negative underneath a root. Remember, anytime we have a negative under a root, we want to pull that negative out in front of the square root as an I, and then leave the 1/3 in there. So that's what I'd be looking for. Again, you could figure out what 1/3 is on your calculator and then take the square root, but this is fine for these problems. Let me do part C. I'll do it over here. So for part C, I have 3x squared plus 15 equals 0. So what I'm going to do is I'm going to subtract 15 on both sides, and I'll be left with 3x squared equals negative 15. I'll divide both sides by 3, which leaves me with x squared equals negative 5. Take the square root on both sides, plus or minus here. So x equals plus or minus I. There's that negative underneath the root coming out, square root of 5. Now, we've done all this. Hopefully you realize that, but we're testing because we really want to make sure you've got this concepts down before you move on to the next math class. All right, let me go ahead and do number 2. Where's my new page? Okay. Number 2, 2a. So we want to solve negative 4x squared plus 8x equals 0. And now what we notice that we have an x squared term, and then we have an x term also, but we do not have a constant, right? We don't have just a number by itself like we did before. We don't have that. So this is very different than the last problem. The way we do this is we get everything to one side so that we have a 0 on one of the sides, which we have here. Once we do that, we look at the left side and we say, or whichever side you have all your terms on, and you factor out a GCF. So what number can go into both of those? Well, I can pull out a 4 or negative 4. I'm going to pull negative 4 out. They both have at least one x, so pull that x out. That leaves me with an x and then minus 8. Be careful on that. Remember, we pulled a negative out, so when you distribute through, this needs to be a positive. That means I have to have 2 negatives there, so be careful. Now, once you've done this, you take each of these factors, negative 4x and x minus 8, you take each of them and set them equal to 0. On the left side, we just divide by negative 4. We get x equals 0 divided by negative 4 is 0. So x equals 0 is one solution. Over here, we just add 8 to both sides. And we get x equals 8. So our two solutions are 0 and 8. Okay, for part B, I'll do B right next to it. For part B, we have, let me get a couple of other things out of here. Let's see, for part B, negative 2x squared equals 12x. So again, we have an x squared term, and we have an x term. We do not have a constant. So I need to get everything to one side. I'll go ahead and choose, even though I can move it either way, I'm going to just subtract 12x on both sides. When I do that, I still have my negative 2x squared. I have my minus 12x. I could not combine those two together. They're not like terms. They would both have to have x squared for me to be able to put these together. So I just leave them. And on the right side, 0. And again, now we look at the left, GCF here. So I have a negative 2x I can pull out. I'm left with an x plus 6 equals 0. Just double check that if you multiply through, you get back this up here. All right, let me get that out of there. Now let's set each of these factors equal to 0. And divide here by negative 2, you get x is 0. Subtract negative 6 on both sides on the other one, you get x is negative 6. All right, let's go move on to C. For C, I've got negative 10x equals 3x squared. Again, x squared term, x term, no constant. So I'll move everything to one side. This time I move everything to the right. I haven't done that yet, so let me just do this. So our left side is 0 now. Our right side is 3x squared plus 10x. We cannot put those together. I have two terms here. I try and look for a GCF. The only thing I can factor out of both of them is an x. So I have 0 equals x, and then I have 3x plus 10. And now I set each of these factors equal to 0 again. So I have x equals 0, and I have 3x plus 10 equals 0. The first one, we're there. There's nothing to be done. On the second one, though, I'm going to need to subtract 10. This is a little linear equation. Be left with 3x equals, and then 0 minus 10 is negative 10. And lastly, we'll divide by 3. So we get x is equal to negative 10 thirds, which is, we could do it as a decimal on a calculator if you want 3.33. Either one of those is fine. So our two answers are 0 and negative 10 thirds. All right, that's number 2. Now number 3, move on here. For number 3A, now we have 2x squared equals 12 minus 5x. So now we have an x squared term and an x term and a constant term, so all three. And the way we do this, problems like this when we have all three, is to move everything to one side to get a 0. So I'm going to leave the 2x squared here. Now be careful here. I'm going to try and get these in order. I have to add 5x, which means I'm going to put a positive 5x on the left side. I had to subtract 12, which means I'm going to have a negative x on the left side. And then on the right side, I'll have 0. Now this is a quadratic equation, right? This is all three terms. We've got the x squared, the x, and a number. Whenever we have this, we either want to factor using AC method or use the quadratic formula. So I'm going to try AC method real quick, see if it works. I do 2 times negative 12, it's negative 24. Have the number in the middle is 5. So I'm trying to figure out two numbers that multiply to be negative 24, add up to be 5. The only numbers that give me 24 are 1 and 24, 2 and 12. Let's see, 3 and 8, 4 and 6. Now, do any of these differ by 5? Looks like these two differ by 5. I just need to get the sign correct here. I need a negative 24, but a positive 5. So if I make a positive 8 and a negative 3, that should multiply to be negative 24 and add up to be 5. So at this point, I'm going to use that super shortcut method I showed y'all. I put the 8 here, put plus, put the 3 here, put minus. I put my x in front here, x in front. I leave a space. Then I have to grab that all-important 2. I have to take that 2, and I either need to take the 2 and put it in front here and underneath here, like this, or I can do it the other way around. And I could put the 2 here and the 2 underneath the 8, which is what I'd like to do because 8 divided by 2 is 4. So I think that would be better. So I'm going to put my 2 in front here and then the 2 under the 8. So what I get is x plus 4, and then over here 2x minus 3 equals 0. Now I have multiplication, so I set each factor equal to 0. And then I'll just solve each of these. So subtract 4 on both sides here. We get negative 4. And then on this one, I'll add 3 to both sides. So we got 2x equals 3. And I'll divide by 2. So your two answers are, let's see, negative 4 and then 3/2. So there's A. Oh, with quadratic formula, I'll do this one kind of quick. If we would have done this with quadratic formula instead, here's how it would have worked with quadratic formula. Remember, I'm using x equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, so my x will be equal to negative b, which is the opposite of the b I have. My b is positive 5, so I take the opposite of that. It'll be negative 5 plus or minus square root. Now I'm going to square my b. So I take 5 and I square it, I get 25. Minus 4 times, now my a here in this problem is 2. It's that number in front of x squared. And then my c is the number in the very back, negative 12. All of it divided by 2 times a. Remember, a was 2. So I get x equals negative 5 plus or minus square root 25. And then over here, when I put these numbers together, I'm just going to look at the 4 times 2 times negative 12. That's 8 times negative 12. And that's going to give you, sorry, having problems here, 96, so, or negative 96. So I'm going to have minus negative 96 all over the 2 times 2 is 4. So x equals negative 5 plus or minus square root. When you subtract a negative, it's the same as adding. So I'm really going to do 25 plus 96. That gives me 121 all over 4. Now on my calculator, or if you just know this, the square root of 121 is 11. So I take the square root, I now have an 11 there. So square root of 121 is 11. And now I do my two cases. I do my addition and I do my subtraction. So negative 5 plus 11 divided by 4 that's 6 over 4. That's 3 over 2. So that's one of the answers. The other one is negative 5 minus 11 over 4. That's negative 16 over 4. That's negative 4. And those match my answers from earlier, doing it the other way, as you can see. So either way, you pick your poison there. All right, let me go and do, where are we at? 3B. So for 3B, I have negative 5x squared plus 3x equals 3. Again, we have an x squared term, we have an x term, we have a number. So we're going to move everything to one side, and you have choices here. I guess because the 3 is by itself, it's easy just to move that 3 over. We're just going to have to be careful with our signs. Negative 5x squared plus 3x minus 3 equals 0. Let me try AC method here. Negative 5 times negative 3 is 15, and then positive 3 here. The things that multiply to be 15 are 1 and 15. 2 doesn't go in there. 3 and 5, and that's it. And we're trying to see if we can get these to like somehow add up to be 2 or they differ. I'm sorry, add up to be 3 or differ by 3. And I can't get it. Even the 5 and 3 here, if I add them, it's 8. If I subtract them, I'm going to get a 2. So I can't do it. Doesn't look like this method's going to work, which leaves me with quadratic formula. So x equals negative b. Here's my b, positive 3. So negative 3 plus or minus square root. Now I'm going to take my 3 again and square it. That's 9 minus 4 times, now let's be careful, negative 5. That's a. C is negative 3. That's the one back here. All of this divided by 2 times negative 5. So we get x equals negative 3 plus or minus square root 9. And then now let me do this. Do these 3 numbers together. So I have my minus sign here. See, 4 times negative 5 is negative 20. Negative 20 times 3 is positive 60. So positive 60 like that. All over 2 times negative 5 is negative 10. Okay, so I get negative 3 plus or minus square root of 9 minus 60 is negative 51 all over negative 10. And the only thing left for me to do is try and break this down here. And I can't break down 51. So I can't take square root of 51. I can't break it down. So what I'm going to do is just take care of that negative. We just don't want to leave a negative under a root. So I'm going to go negative 3 plus or minus. The I comes out square root 51 all over, negative 10. And that's it. We can't do anything else here. Remember, you can't cancel. You can't mess with these two. The only way you could is if there was something out here that they all had in common. So that's my answer. All right, let's look at 3C. I'll do a new page. 3C. We've got 10x equals x squared minus 2. I'm going to move everything to one side, so I'm going to move that 10x over. So I'll get 0 equals x squared. Make sure I put this in the right order. It's negative 10x because I subtracted 10x on both sides, and then minus 2. So make sure we have descending order, highest power of x down, before you start doing anything. AC method, let me try it real quick. I'm taking a 1 in front of the x squared, and I'm multiplying it by negative 2. Then I get negative 10 here. There's no way this is happening. The only way to get negative 2 is to use a 1 and a 2. And there's no way those are going to add up to be 10 ever. So stuck with the quadratic formula. So x equals negative b. Now be careful here because b was already negative. So when we do a negative negative, it's positive. Plus or minus square root. Now remember, when you square b, no matter what the sign was, it's going to be positive here because negative 10 times negative 10 is 100, positive 100. Minus 4 times 1 times negative 2 all over 2 times a, which is 1. So 10 plus or minus square root. Now let me do this one quickly. This is 100 Then we have, let's see, 4 times 1 times negative 2 is negative 8. So I'm subtracting a negative, so that's 108. It really turns into adding 8 instead of subtracting it. And now I'm going to see if I can break down 108. So does 108 break down to be anything that has a perfect square? So I get my calculator out. I try 4 first. Does 4 divide into 108? Yeah, 4 goes in there 27 times. Hey, but wait a minute, 27 has a 9 in it, so maybe something bigger went in there. Let me do 9 in 108. 108 divided by 9, that gives me 12. So that's a pretty big perfect square, but I might be able to go even bigger. What's the next perfect square? 16? Let me do 108 divided by 16. Doesn't work. How about 108 divided by, what's our next perfect square? 25? Remember, our perfect squares are 4, 9, 16, 25, 36, 49, and so on. So I'm just trying to divide 108 by all these. 108 divided by 36 is 3. 36 and 3. That means that I can take the square root of 108 and look at it as being the square root of 36 times the square root of 3. Square root of 36 is 6, and then times root 3. So basically, I can rewrite square root of 108 as this. So I have this equals 10 plus or minus 6 root 3 all over 2. And now one last step. All of these numbers are divisible by 2. So I'm going to reduce everything by 2. So 2 goes into 10 5 times. 2 goes into 6 3 times. The root 3 stays there. Then on the bottom we have divided by 2 goes into 2 1 time. Now I don't technically need to write the 1 divided on the bottom, so I can just put 5 plus or minus 3 root 3. That's what we're looking for. All right, now let's get on to kind of the new material, which is number 4. And I'll do 4a first. We're trying to sketch y equals 2, let's see, x plus 1 squared minus 8. So what we need to first realize is that this is a parabola and that we want to sketch it. So there's the set of steps. The first step was to determine the form. And the form of this is the standard form. Remember, standard was y equals a x minus h squared plus k. Remember, the h and the k are very important. They help us get our vertex. So now what we'll do is we'll identify what a, h, and k are. A for us is 2. It's the number out in front. H is always the opposite of what we see in here. So h is negative 1. And k is always exactly what we see on the outside, so negative 8. All right, second step. Does this open up or down? It opens up. Why? Because a is 2, and that's a positive number. Step 3 is to find the vertex. The vertex of this is hk, which we know because we know what h is. It's negative 1, and we know what k is. It's negative 8. So we have vertex right away. It's pretty nice. Fourth step is the quick sketch, and we do this to try and determine our x-intercepts. So quick sketch, I go to the left 1 and down 8, and I have a vertex down there somewhere. I don't really care too much. And it opens up. So this parabola I know from here goes up, and that means it's going to hit the graph twice. So I'm going to have 2 x-intercepts. So let me go ahead and try and find those over here. X-intercepts. To get the x-intercepts, what we do is we take our equation, we replace y with 0. So we replace that y with 0, it becomes 0 equals 2x plus 1 squared minus 8. So the standard way of trying to solve this is to get this piece right here, x plus 1 squared by itself. So add 8 to both sides of the equation to get 8 equals 2 times x plus 1 squared. Divide both sides by 2. So I added 8. Sorry, let me back up here. I added 8 to both sides. Now I'm going to divide both sides by 2. That'll give me 4 equals x plus 1 squared. And now a very important step, I'm going to take the square root on both sides. And remember, when you do that, plus or minus. So the square root of 4 is 2, and so we have plus or minus 2 equals, now this square root and square cancel, so we get x plus 1. And now I will subtract 1 on both sides to get negative 1 plus or minus 2 equals x. Be careful there. The big mistake I was seeing is people were subtracting 1 from 2. You can't do that. You have to say, I'm going to take negative 1, I'm going to add 2, and negative 1, I'm going to subtract 2. So that's why I wrote it this way. And now let's do that. What would negative 1 plus 2 be? Well, negative 1 plus 2 would be 1. Okay, so that's what I get when I do negative 1 plus 2. And now if I do, try and get these out of here. I don't want to erase them, it's okay. If I do now negative 1 minus 2, right? I get negative 1 minus 2. That gives me x is equal to negative 3. So that's it. Those are 2 x-intercepts. Next step is, let me see, that was step 5. Step 6 is the y-intercept. To get the y-intercept, you plug 0 in for x. So I'm going to plug 0 in right there, plus 1 squared. What was it, minus 8? Yeah, minus 8. So I'm plugging 0 in for x into the original problem. So now this gives me y equals 2, and then 0 plus 1 is 1, so 1 squared minus 8. 1 squared is 1, so 2 times 1 is 2, minus 8, which gives me negative 6. That's my y-intercept. So now I'm ready for step 7, which is a sketch. Okay, my vertex is negative 1, 8. 1, 2, 3, 4, 5, 6, 7, 8. There's negative 8. So I'm going to put my vertex there. I have x-intercepts at 1 and negative 3. So here and here. I have a y-intercept at negative 6. Oh, negative 6 is here. And remember, we have our, well, that doesn't work very good. We have what we called our axis of symmetry, which is kind of a vertical dotted line that goes through the vertex. And our problem must look like a U, and it must look symmetric to that. So it's got to go up through here. Whoa, that did not work. This. And then pretty much do the same thing on the other side. All right. That's it for 4A. Now, I'm going to do 5A now. That way you have something you can do at home. 5A. So 5A, we have y equals negative 2x squared plus 4x plus 5. And now we're trying to sketch this. So same thing, this is a parabola. The form of this is non-standard. And so for non-standard form, looks like this: y equals ax squared plus bx plus c. So we have our a, our b, and our c right there. So let's write those down. A is negative 2, b is 4, c is 5. All right, step 2. This thing opens down. Since a is negative 2, it's less than 0. When it's a negative number, it opens down. For step 3, the vertex, this is whenever we're in non-standard form, we have to use a formula to get the vertex. The formula was h is equal to negative b over 2a. Now for us, b is 4, so negative 4 over 2 times, now a for us was negative 2. Be careful with your signs here. That's negative 4 over negative 4, that's 1. Very nice. K is what we get when we plug our answer here. 1 into our equation up there. So we're going to have -2, then we're going to square 1, plus 4, we're going to multiply by 1, and then we're going to add 5. So we get, let's see, 1 squared is 1 times -2, that's -2. Then 4 times 1 is 4, so plus 4, and then plus 5. This should give us 7. So our vertex is the point 1, 7. Now, quick sketch. I go out to the right. Let me do it this way. Go out to the right 1, go up 7, draw a vertex. I must open down from here. That means I hit in 2 places. So on step 5, when I get the x-intercepts, I'm going to need to go ahead and realize I'm going to have 2 x-intercepts. So to get x-intercepts, I replace y with 0, which means I'm going to take the original equation, and it's going to become equal 0 like that. And now, at this point, I have a quadratic, and so I need to solve this. So this is kind of like what we were doing in number 3, part A, part B, and part C. I have, the squared, I have the x, I have the number. So you're essentially going to be trying to use either factoring AC method or quadratic formula. And try a quick AC here. -10, that's -2 times 5. Ooh, wow. And then 4 here. Let me see. Can I get that to work? No, doesn't look like it. Oh well. So quadratic formula is all I've got. So quadratic formula here. We're going to have x equals -b plus or minus square root b squared is 16 minus 4 times a is -2 times c is +5, all divided by 2 times a is -2. All right. I get my calculator out because I'm going to need it here. -4 plus or minus square root. So I'm going to do this first. That's 4 times -2 is -8. -8 times 5 is -40. So I have 16 minus a -40, which is the same as plus, right? So 16 plus 40 is 56, all over -4. Now, because these are x-intercepts, I'm going to have to get on my calculator. I'm going to have to figure out what the square root of 56 is. So the square root of 56 on my calculator is about 7.5. We'll just go 1 decimal point, 7.5. I'm actually getting 7.48331, but 7.5 will work over -4. Now, remember, don't cancel those -4s. You got to put everything together on top first and then come through at the end with that division. So I'm doing -4 plus 7.5 and divide by -4, which is 3.5 divided by -4, which is -0.875. And then I do -4 minus 7.5 divided by -4. So doing this on my calculator real quick, I get a negative on top and a negative on bottom, which is positive. So I'll have 2.875. It's about almost -0.9 and almost 2.9. So let's remember that when we go to graph. Next thing, step 6, y-intercept. Well, the good thing is when you have the non-standard form, it's always c. And c in our problem was 5. So our y-intercept is 5. And now I'm ready for a graph. So I'm going to try and fit it all on this page here for us. My vertex was 1, 7. So I go to the right 1. I go up 7. 1, 2, 3, 4, 5, 6, 7. I'm going to put my vertex there. I have an x-intercept of about 2.9. So here's 2, here's 3. So it's almost at 3. So I'll just put it about right there. And then I also have another one at -0.8. So here's -1. -0.8 is right before I get to -1. It's almost -0.9. I have my y-intercept of 5, which is right here. Remember, I have my axis of symmetry that goes down like this, and I need a U-shaped thing that passes through these points. It's going to go like that. Oh, come on. They're pretty good there. And then over here. There we go. All right. So that should take care of 5A. I'll leave 5B and C for you also. Just keep in mind that, you know, on those you might run into some issues with the numbers being a little messier. Like on this one, our vertex came out to be, you know, our H was 1. Well, on other problems that might turn out to be something different, you know, like on part C, 5C, that number is going to be nasty because it's B, which is negative B over 2 times A, so you get negative 9 over 8. So I would recommend you turn that into a decimal, which would be negative 1.125, and that's the number that you'll plug in. So just keep that in mind. I'm going to erase this because I'm going to print this out. I don't want people to be all confused with what that was. Just keep it in mind. All right, and finally, what I'll do is look at number 6. So number 6 and 7, we're using the same formula that we did in class that has to do with objects falling on Earth. 6 has a ball being dropped from 400-foot building. So this is the formula that we used. And if you're just going to take a ball and drop it from a 400-foot building, so let's say that's 400 feet. If you're just going to take a ball from here and just drop it straight down, then that means we're not giving it any speed. We're not throwing it up, we're not throwing it down, we're just dropping it. So that V0 in the problem is going to be 0. And the fact that the height was 400 feet, that corresponds to that number. So that number right here should be 400. So the equation that we wind up using, which will be our parabola, is this. 0 kills off everything there, plus 400. And so you're basically sketching. You're going to go through and sketch this. That was part 1, is to find the equation. Part 2 would be to sketch the parabola. So you have to go through that seven-step process, which I'm not going to do. I'm just going to show you the result of it. You should get a y-intercept up here at 400. That should also be your vertex. And then, real quick, I need to do something on my calculator. Oh, is that right? Wow, that worked out pretty nice. And then you should get an x-intercept here at 5. And then what you'll have is your parabola that opens down like this. Now, remember in class, we only drew stuff on the right side of the y-axis and above the x-axis. So it doesn't make sense to have any parabola anywhere else, because this is time and this is the height. So we don't have any negative time, and then once the ball hits the ground, it's not going to go through the ground, so we're just going to leave it like that. So we can answer the other parts of this question. Part 3, what was the maximum height of the ball? Well, that would be when the ball was right in here. That's the maximum height. And that would be 400 feet. And then to answer 4, how long does the ball take to hit the ground? Well, that's a time measurement, and it's exactly when we get the x-intercept, which is going to be at 5, but that's measured in seconds. All right, so that's pretty much the way you do number 6. Of course, I skipped the 7 steps on part 2. You would need to do that. Now, number 7, problem changes a little bit, because this time the ball's still on a 400-foot building, but we throw the ball up and then it comes back down. So it's a little bit different path. So the equation, d equals negative 16t squared plus v naught t plus d naught, is going to change, because our initial velocity, since we throw the ball upward and they tell us at 30 feet per second, that becomes a 30. Now our building is still 400 feet, so that's where we start from. So our equation for part 1 is d equals negative 16 t squared plus 30 t plus 400. All right, and I think what I'll do is I'm probably going to work through this in class, finish it out, but let me put here, just so we have it, this might take me just a second, let me just put what we're going to get. That way you can refer back to it if you need to. All right. I'm waiting for my calculator to do something here. Part 2 would be our graph. I'm still here. All right, it looks like, okay. So on our graph, here's what you'll get. You'll have a y-intercept, again, a y-intercept of 400. And then at 0.94 about, you'll have your vertex up here at 414. So that would be your vertex up here. I'll write that as a point right next to it. It's 0.94, 414, and some change. It's like 0.1. And then your x-intercept is going to be at 6.02. So I'll just put 6.02. So your parabola has an axis of symmetry like this down the vertex. The parabola must open to the left like a U, and then to the right like a U, like that, and then come down here and hit. And again, because of the ball falling, we don't do anything on the left side or down here. So to answer part 3, what you'll do is find the maximum height. That's going to be this height right here. That's your max. So that's going to be 414, roughly 414 feet. And how long does the ball take to hit the ground? Well, that's this, 6.02 seconds. So compare that to the answer from before. And remember, I skipped the whole sketching because that's just kind of what you need to be able to do now. If you go up, the first ball was just dropped from 400 feet. So, of course, the highest it would ever be is 400 feet, and it takes 5 seconds to hit the ground. But if you throw the ball upward with some speed first, it's going to go up. I mean, it's going to have a maximum that's higher than if you just dropped it, and then it's going to take longer for it to come down and hit the ground. Well, just about a little bit over a second longer. All right, well, I hope that helps for the exam. See you all soon.